Hi class, let's take a look at problem 8, and they want us to find the volume of a cone given the following measurements. So in this case, they're telling us that R is equal to 5 and H is equal to 12. And they also want it as an exact in terms of pi and then a decimal approximation. So in this case, the volume, it's going to be calculated by the following formula. This is 1/3 pi times r squared times the values of h. And we're going to have r equaling 5 and h is equal to 12. And both of these are going to be in inches. So let's evaluate this formula. So we're looking at v is equal to 1/3 times the values of pi times 5 to the second times 12. And we can actually factor. So let me just multiply the 5. So v is equal to 1/3 of pi times 25 times 4 times 3. And what I'm trying to do here is cancel the 3 that's part of the formula, which is 1/3. And this is gonna leave us with pi times 25 times the values of 4. So the volume as an exact value, it's going to be 100 pi. And then the actual units are in inches. So technically it'll be inches to the 3rd power for this one. And let me actually pull out the calculator. So we're going to be multiplying 100 times, and then they want pi 3.14. That's just going to be 314. So approximately 314 inches to the 3rd power. And let me use the proper the proper key for the pi. So 100 times the values of pi. This is going to give us 314,159. So approximately 314. And then it was 159. So 159. And this is going to be, once again, inches to the 3rd power. Okay, so let me write it as a sentence. And in this case, we're just going to say that the volume is V, which is equal to 100 pi inches to the 3rd power, which is approximately 314 inches to the 3rd power, since they just wanted us to use 3.14. And that's actually it for problem 8. Let's move into problem 9. And for problem 9, we're given the trajectory of a ball, of a golfer. You can see the actual trajectory creates a parabola. And the equation here, h, it's given by this sketch. So what they want us to find is the actual height at 3 seconds. So what they want us to do is find h when t is equal to the values of 3. And we're talking about seconds. So at 3 seconds, we're going to actually find how high is the ball. In this case, the formula is h is equal to negative 16 t to the second plus 80 t, and we're going to be plugging in 3 into the formula. So let me rewrite it. Our value here, h is equal to negative 16 times 3 squared plus 80 times 3. And we're looking at h is equal to negative 16 times 9 plus technically that's going to be 240. Since 3 times 0 is 0, 8 times 3 is 24. And the 9 times 16 is going to be negative 144. So h is equal to negative 144 plus the values of 240, which is going to give us the h value of 96. And let me just double check the calculation. Okay, we're good. So you can actually see, well, it's kind of hard to visualize here, but you can actually see here the coordinate point of the trajectory of the ball, that at 3 seconds, it's at 96 feet. That's the coordinate point embedded here. It's just a little bit too small on the graph, but you can see 396. Okay, so let me write the final sentence. And in this case, the height of the ball after t is equal to 3 seconds is h is equal to 96. And in this case, the units are in feet. So 96 feet. And that's actually it for this problem. A lot of the applications that we're going to be talking about are going to have parabolas. Here you can see the perfect parabola that is created, and at t is equal to 3 seconds, you can see the actual height of it at 96. That's it for this problem.